Hello everyone, my name is Juan Amieva, and today I will be presenting the application of electrosprayed Minocycline-Loaded PLGA Microparticles for the treatment of glioblastoma. Now, a little background on my project is that glioblastoma multiforme is one of the most common and aggressive forms of cancer, in this case being brain cancer, with unfavorable prognosis due to high levels of recurrence despite treatment. Minocycline, our drug of interest, is a tetracycline-based derivative that has proven to be a promising novel candidate against glioblastoma due to its ability to inhibit angiogenesis and tumor growth. Now, our polymer of interest, being PLGA, is a widely used biomaterial for drug delivery due to its inert properties of biocompatibility, versatility, and easily tailored degradation rates with known prior success. Now, our way of fabricating microparticles, being electrospraying, is a promising microparticle fabrication method, which allows for narrow size distribution, scalable fabrication, and high entrapment efficiency, requiring only minimal setup at low cost. Now, the objectives of this study is to determine the optimal electrospraying parameters to fabricate Minocycline-Loaded PLGA microparticles with high drug loading efficiency, and suitable morphology for the treatment of glioblastoma. Now, it was hypothesized that the electrospraying parameters, such as the type of solvents used, the drug and polymer concentrations, collection plate distance, voltage, flow rate, and collection method would have an effect on microparticle size, morphology, drug loading, and loading efficiency. Now, for our methods, it is separated into three different lab procedures. First one being solubility, in order to determine how much drug and PLGA is able to dissolve within different solvent ratios. So we added 1 milligram of drug or PLGA and dissolved in a specific solvent at different ratios. We vortexed until it was fully dissolved, and added 1 milligram of drug or PLGA if it was successful, and repeated until the solution was saturated. Now, in order to fabricate the microparticles, we did use vertical electrospraying, in which we prepared the drug polymer solution and transferred the solution to a glass syringe. We then tested the spraying parameters and collected in the medium, either decant or evaporation collection method. And then we freeze overnight, lyophilize, and image by using the scanning electron microscope, or SEM imaging. As you can see on the right side here in the methods, you can see the vertical electrospraying setup, and the parameters being the flow rate of 2 milliliters per hour, voltage 9 kilovolts, the distance 18 centimeters, and the collection medium, which is on the Petri dish or collection plate, isopropyl alcohol. Now, for drug loading and loading efficiency, we weighted triplicate samples of each testing microparticle, added DMSO and vortex, plated in triplicates per sample, and read the absorbance at 350 nanometers using spectrophotometer. For our results, we can see here, for minocycline and PLGA solubility, there are 5 different tables. The first one describes the amount of minocycline dissolved in a milliliter of 100% of all solvents. Now, as you can see highlighted in green, methanol was the highest, that yielded 44 milligrams of drug solubility. If we moved on to a 70-30 ratio with all solvents with DCM, DCM and methanol, again, were the ones that yielded the highest drug solubility. Now, you may be wondering why we use DCM, but if you go to table 5, you can see that the amount of PLGA was tested in all solvents, and DCM was one of the highest drug solubility for PLGA. We did see a pattern that DCM and DMSO and DCM and methanol yielded the highest out of all. So we did go ahead and did a 90-10 and 80-20 solvent ratios for DCM and methanol, and DCM and DMSO. And DCM and methanol were the highest, with 4 milligrams of drug and 8 milligrams of drug for 80-20. As you can see, also highlighted in red, the isopropyl alcohol on table 1, 2, and 5. As I mentioned before, we did use a collection medium for the vertical electrospraying, and we did decide to highlight isopropyl alcohol because it did seem like the best solvent for collection medium, because it does not have the ability to dissolve the drug of interest, which is minocycline, as seen in table 1, and the polymer of interest, which is PLGA, as seen in table 5. For microparticle size and morphology, you can see here 8 different STM images. With main difference between them, they're all going to be 90-10 DCM methanol. but there's a decant collection method and an evaporation collection method. The decant collection, meaning when we electrospray in the collection medium, after 5 minutes, we decant the excess isopropyl alcohol and we leave the remaining to evaporate, normally within 2 hours. And the evaporation collection method, we vertical electrospray on the isopropyl alcohol and leave it overnight to air dry and therefore evaporate. Now, there we did run a 2.5 milligrams and a 4 milligram electrospraying to see the main differences and the impact on the parameters within the electrospraying. We were able to observe in the SEM images spherical and smooth microparticles that is successful in a way that it avoids burst release in the near future that does come with porous surfaces. Now, another thing to note is that there was 2 size distributions of particles observed, with the larger microparticles as seen on the first image on the top left, usually ranging about from 60 to 80 micrometers in range, with smaller particles from 1 to 4 micrometers in range on the surface of it. As we move on to drug loading and loading efficiency, all results were significantly different, in which microparticles collected by the evaporation yielded significantly higher drug loading and loading efficiency compared to those by the decant collection method on both the 2.5 and the 4 milligrams of drug concentration. For a conclusion, VCM and methanol is the optimal solvent combination for minocycline, and higher amounts of methanol usually result in higher drug solubility, as you can see in the table 2, 3, and 4. Isopropyl alcohol is the best solvent for the collection medium due to its inability to dissolve minocycline and PLGA, therefore better in trapping the drug in the microparticle after the electrospraying process. Both methods of collection resulted in spherical microparticles with a smooth surface. And as mentioned before, there were 2 size groups observed with larger and smaller size distribution of particles. The evaporation collection method, in comparison with the decant method of collection, allowed for higher drug loading and loading efficiency in both concentrations, 2.5 milligrams and 4 milligrams of drug concentration. As for future studies, the fabrication of microparticles with 80-20 and 70-30 ratios will be investigated in an attempt to obtain higher drug loading and loading efficiency compared to the ones we did test, which is the 90-10. Thank you for your time.